Good morning, good afternoon. Thank you for joining us today at this month's Tech Talk. Today's guest is Michael Skolick, who is the managing consultant and architect for enterprise studios for HCL Technologies, and he's going to be talking about Docker and high-performance architecture. And I am Bill, and with me is Aran, and we're going to be your host today as we get through Docker and high-performance architecture. Now, as we get started, if you can't hear us, yes, we are talking. So here's how you basically get started. If you look at the telephone audio up in the upper right, locate where it says audio, select the telephone, dial using the number or the information provided on your screen, not what you're seeing on the screen we're showing you. Once connected, you're going to enter your audio pin so you can identify your line, and then you're successfully connected. If you get disconnected for any reason, just simply log back in again. So using your control panel, there is a left and a right arrow. It's an orange arrow at the top of the screen. You can expand and collapse your panel simply by hitting that button. You can view and select your audio if you find that your phone's not working and you want to switch over to your computer. This is where you would do it. Submit your question or comments. This is a very important section as we get to Q&A at the very end. And everybody is on mute for recording purposes. This recording will be available later on today or early tomorrow up on API Academy. I want to remind everybody that we have a reboot of the API Academy. It is live with its new look. We have new how-to videos being published a couple of times a week, as well as thought leadership blogs. I do highly recommend checking it out. And with that, I'm going to turn it over to Aran real quick to talk about the upcoming Tech Talks. Take it away, Aran.
Thanks, Bill. Just wanted to make sure that the people on the call were aware of, as we get these Tech Talks going, we're going to publish the topics for a month or two in advance. So, really happy that Michael is going to be talking today about containers and productionizing those and those kinds of things, which is great. Next month, we have a talk on GraphQL and how the gateway can play a key role in protecting and providing GraphQL endpoints to customers. I think that's going to be really exciting because that's definitely becoming a really hot topic. And then the month after, we've got a talk on using our OAuth toolkit to provide OAuth and OpenID Connect capabilities around securing your API. So they're our next two topics. The rest of the list is up to you guys. So if you've got topics that you want us to cover, you've got exciting things you want us to talk about, or you've got things you want to present yourself, please get in touch with Bill or myself and let us know, and we'll definitely try and get those on the list. So next 2 months are booked. If there's demand, we could change those, but I'm pretty sure there'll be interest to everyone. Anything else, please just let us know. We're happy to get the right people on the call to make these calls really valuable to yourself. So Bill, back to you, and Michael.
Great. Before we turn it over to Michael, one thing about Tech Talks, just a little particular to file away in your brain. They are always on the last Wednesday of the month, so just kind of file that away. Except for the last 2 months of the year, we're pretty confident nobody wants to sit there and watch a Tech Talk the day before Thanksgiving or the day after Christmas. So we're going to be adjusting those 2 months. But the rest of the time, it'll always be the last Wednesday of the month. And with that, I'm going to turn it over to Michael Skolick, who, as I said before, is the managing consultant and architect for enterprise studios by HCL. And he's going to be talking about Docker and high-performance architecture. And give me 1 second to do this amazingly complex technical feat right here. And take it away, Michael.
Okay, good morning, everybody, or noon or afternoon, wherever you're located. Can you hear me well, Bill?
Absolutely.
I can hear you great.
Okay, good. So, battle with technology too, because the first time I do a Tech Talk, so normally live. So that's my agenda for today. I have to get rid of this here. So topic is Docker and high performance architecture for layer 7 API gateway. I would like to introduce myself and the company I'm working for, because after CEO was dissolved, there's some confusion who we're working for. Then I want to take you a little bit back to talk about the evolution of the gateway and why we got to this architecture that I will be presenting. That includes challenges for Docker and high performance implementations, And we'll talk about the relevant components, which is mostly database, metrics, audits, logs, internode communication, OTK. And then I'll show you the reference architecture, which is a logical architecture. It can be implemented in many ways. Okay. So, but a bio about myself, starting backwards, I was educated in Germany, University of Bonn, master in mathematics and a couple of BAs. Then I slipped into what today you would call a startup company. Started the kitchen table, 7 years later, 50 people, multiple offices around the world. I was a CTO. Then the company was bought. I joined Sun Microsystems, which was very hip at that time, and then moved to Canada 25 years ago in '94, or 26 almost. Started from scratch and had my own company for 15 years, did consulting around the world for major companies, and finally ended up in 2011 with Layer 7. I was the third professional services consultant, yeah, worked there ever since. Layer 7 was then swallowed by CA, and CA was bought by Broadcom. We'll get there in a moment. So right now, my role is mostly architect and trusted advisor to a couple of companies, and I manage a team of consultants. 2 slides about who HCL Enterprise Studio is, because it's fairly new, so a lot of people might not know who we are. We evolved from CA Technologies, then bought by Broadcom in November 2018, and CA was then split into at least 2 parts. One was the old CA kept by Broadcom, and the services department was resold to HCL Technologies. And HCL Technologies formed a, let's say, subgroup within HCL called Enterprise Studio. So what we're doing, we are the preferred provider for professional services and education for Broadcom, enterprise software solutions, and beside the regular HCL services that is applied by the mother company. So Enterprise Studio, to be simple, is mostly the old CA services department. So take you back to old Layer 7 days and clustered environments. I'm going to go back to this stage just to explain where the problems were and how they were resolved over time, step by step, that led us to the current architecture, reference architecture, so that you understand why we choose that way of architecture. So at the very beginning, we had gateway clusters. 2 of the nodes were database nodes. So they were configured to hold the MySQL database, and the database was replicated between these 2 nodes in an active-active fashion. So that meant regardless which node were updated or which database was updated, it was replicated to the other node immediately. And if one went down, it resynced. So what we did is all the nodes in the cluster were connecting to the primary database. And that was synced over to the secondary database, in this case B. So in case there was a failure, we switched over to the secondary database and continued processing. So there was only a delay of maybe a second or even less that you would even notice. And then the gateway sticked to that secondary node and pinged the primary in the background. So there was no, I'll say, delay trying the first database and then switching over. So it's stuck to the second database until the primary was back up, and then every node switched back. Go back here. So that means in a cluster, we had 2 nodes that were processing the database on top of the traffic that is coming in. All the other remaining nodes in the cluster where the database was not active, and they were just connected to the primary database. So what were the advantages? It's a fast and easy installation. To set up a cluster after you got experienced, it takes me about 15 minutes to set up a cluster. So setting up the two database nodes, run 2 scripts on each node to establish the active replication, and just then configure the nodes to use these 2 databases. So you just simply could scale horizontally by just adding a node to the cluster. And because all the nodes are connecting to the same database, the new node had to connect to the database and inherited everything that was present, meaning database connectivity, policy code, services, cluster-wide property, anything that was there. It also inherited all the shared components. So if you had LDAP connections, if you had queues, ports, everything was automatically known by the new node that was added to the cluster. So it was very convenient. Same applies to shared extensions like OAuth Mag. And it was very convenient to maintain the policy code. You could connect with a policy manager to any of these nodes, do your changes, save it, and within a second, all the other nodes were up to date without redeploying anything to all the other nodes. We had automatic counter synchronization. What this means, there were 2 assertions that had to synchronize counters through the database. That's throughput quota and replay attack. So they were writing the counter to the database, and the other nodes were reading that counter, and you had a cluster-wide synchronized counter for these assertions. Backup and restore was easy. You just restored the database, connected all the nodes, and you were up and running. So like every system in the world has yin and yang, so it has advantages and disadvantages. So the limitations is you could only grow a cluster size to 6 to 8 nodes. You could push, we'll see later, you could push it out a little bit. That was the first iteration of tuning it, but it was limited in a number of nodes. Why? We get to that later. We had replication failures. It could be a network, it could be one node was not up, whatever the issue might be. But the problem was once replication broke, the replication logs were stored in the file system, and that caused gateways to crash because the file system was full. There was problem with multi-data center installation. You couldn't span a cluster throughout databases because of the latency between the nodes and the database replication. Version upgrades were painful. You had to break the replication of the gateways of the database, update a few of them, then switch back and resync. It was a complicated process. So the limitation of the cluster that I had, like you see up there, 6 to 8 nodes, had mostly to do with the MySQL performance. The reason for that is the gateways were constantly writing their status to the database. I'm up and running, and I posted that in many requests. It was writing the metrics to the database, and on top of that, the metrics get rolled up. That means the requests were rolled up in a 5-second bin, in a minute bin, an hour bin, and in a daily bin. So that means the data was consolidated, deleted, rewritten, and that put a huge load onto the database. Then there were audits. Audits are kind of debug messages or messages created by the gateway written to the database. And we had clients that crashed even their external database cluster because you could externalize the audits. writing too many audits, and it put a huge load onto the database. And of course, we had the counter synchronization. So the first iteration to optimize this was to just reserve 2 nodes in the cluster, the database nodes, and not route traffic to them. So the gateway process was not active. We had processing nodes and we had database, and you could tune both from the configuration point so that they were tuned to optimal performance. So for the database nodes, you didn't need a license because there was no gateway process present. But so you get more CPU and disk I/O for the throughput. So we had a client when I joined in 2011, that was 12, that had up to 10 nodes, and they were processing 4,000 to 5,000 transactions per second. That was about the maximum you could get out of this system. That's where the bucket stops. Beyond 10, talking to support, that was not really an option. So the next iteration is, we started promoting this about 2-3 years ago, is overcoming all the deficiencies that we had with the clustered environment. Because now CA took over and we had more enterprise clients that needed need to process more transactions. So we needed a new architecture. So what we did is we eliminated the database replication. So we had single nodes only behind the load balancer, and you could extend this more or less unlimited because they were all single nodes with their own database. The access to the database was faster because you could use named pipes instead of the network step to connect to it, and you got rid of the overhead of DB clustering and replication. So the advantage is you can scale more or less unlimited. There's no dependency between nodes. Upgrades are simple because you can just upgrade one node without affecting the rest, and you get higher TPS. The disadvantages are it's a more complex migration process because now you have to migrate policy code and services from the lower environment to each node. Thank God we got GMU at that time, so you could automate this through a script that can run to all the nodes, and you can have multi-database, multi-data center support. The problem was now there is no counter synchronization. So for replay attack and throughput quota, there was no database to sync to and to synchronize the counter. So you had to do the math yourself and adapt the assertions accordingly, so to get an approximate rate limiting replay attack and throughput quota. And there was also no metric consolidation because each node recorded their metrics locally. And there was no place to consolidate them. And there was a problem with log and audit handling. So that's how a database, how a multi-data center set up at that time for a whole bunch of clients that we had when CA took over, international clients that had data centers around the world. Okay, so we even outgrew this. So what we're talking about now is, remember we had 4,000 to 5,000 transactions per second in a clustered environment. Now the goal is to have 5 to 10 billion API calls per day. Because it's not equally distributed during the day, at peak times, we're talking about 80 to 150,000 calls per second, which is quite different from what we had before. So far we eliminated replication failures, version upgrades, horizontal scaling limits, and some TPS transactions. But we still have the MySQL on each node, which at some point you will run into limitations based on the right throughput of the gateway and the database, especially MySQL. There's still no counter synchronization. In that massive deployment, you have problems with installation because you have to install 100 or 200 gateways, which is a lot of work. Policy migration is difficult. No metrics are consolidated. You can't implement auto-scaling, and problem with monitoring. So what is the solution? And they correlate like on the same line. So overcome the MySQL performance limitations. Solution is we don't need a database. For counter synchronization, we have to have something that synchronizes in memory. For installation and policy migration is deployment from a repository, meaning the gateway as a file. No metric consultation is in-memory metrics collection and then off-sourcing it to an external tool that handles this. Audit and logs are handled by a log forwarder or sending messages to Splunk, or not to Splunk, sorry, to a syslog server. Could be Splunk as an example, but can be any other tool. For auto-scaling, you can use Docker and Kubernetes. For monitoring, you could have a monitoring agent like AppDynamics or APIM. So that means, as a result, the gateway becomes a stateless processing engine for APIs, and all collected data will be offloaded to external third-party tools. So the goal is to have the gateway as a file. So how do we do this? We called it, or somebody called it, leader-follower model. So what does it do? So you come from a lower environment and you push all changes and services via GMU to what we call a leader gateway. It's a non-processing node, like a dev environment. Just a simple database and doesn't have to process any traffic. It's just there to receive all the updates from the lower environments and then use the GMU to export the complete gateway to a bundle, which is controlled by a source code control system, for example, Git. So you have now a representation of the gateway in a file, in a bundle. So now you have what we call follower gateways. So the follower gateways start up and read the bundle, and they just process. Everything else, and there's no database. So everything else that the gateway collects in terms of data, meaning metrics and logs, are offloaded to an external system. And you can rip it down. When there's an update, you create a new bundle and you restart the follower gateways. The implementation, so this is independent of the implementation and the form factor. This is the logical architecture. So that means the follower gateway can be a VM, can be a software appliance, and it can be a Docker container. I mean, obviously it's more targeted towards Docker container than the other one, but some clients are not ready yet to have a Dockerized environment. So we implemented 3 different ways, like some of my consultants implemented this in a VM environment, in a Docker environment. Well, software is we skipped, but these 2 we just test implemented. So we did a reference implementation. So the environment is Kubernetes, and the leader gateway is a simple 1 gateway VM. And in this use case, we added the portal, and we also added OTK, which you'll see in the next chart. So third-party components is a Hazelcast server that is used for counter synchronization. If you have a few nodes, you don't need a server. Hazelcast is built into the gateway. You can activate it. But if you get to a bigger environment, I think above 5, that's what Iniri told me, or if you want to go across data centers, you need a Hazelcast server to synchronize the counters. And that will take care of synchronizing the counters for replay attack and throughput coda. We used App Dynamics for monitoring and metrics visualization. So the metrics are now collected in a memory buffer and then offloaded via HTTPS call or queue or whatever method you want to use to some external system. In this case, we just called an endpoint in App Dynamics and dumped the data there, and the client created a dashboard to visualize the data. For OAuth, we used Cassandra DataStax. DataStax is just a professionally it's not the non-open source version of Cassandra. Metrics offloading was done for Kafka. So we dumped, or you can use any other queue. So they were just dumped to the queue because of the high volume. Just dump it, forget it, and continue processing. And some system, regardless which one, will handle the metrics. For logs, we use Splunk forwarders and Git as a repository system and Jenkins as a build tool. So that's how the environment looked like. It looks very, very complex, but at the end, it is not. So down here, hope you can see my cursor, is the leader gateway, which inherits all changes from the lower environments. And cursor there. So down here, you will create a bundle that is stored in a repository system. And then you have your build tool that builds all the followers. So they're identical clones of your leader gateway. And you can have as many as you want. The metrics are gone to Kafka, monitoring going to App Dynamics, and they also used it from the queue to offload to App Dynamics in this case. And there's your OTK. In that high performance environment, I'm not sure if Oracle can handle load, especially if you have multiple data centers and you want to synchronize between multiple data centers. I know Oracle has some tools for that, but most clients at that scale decide to jump to Cassandra. And here there is your Hazelcast server that synchronizes the counters between the nodes through even between data centers. So the solution is Treatway Gateway as code, and it has three components: is the environment configuration, meaning the cluster-wide properties, service configuration, like the service properties. Not many clients are using it. The policy code. Nodes will be deployed from a repository and managed by a powerful container system, for example, Kubernetes or OpenShift or any other container system that you might choose. You can have rolling upgrades because there's no need to upgrade a gateway anymore. You create a new image and you just restart the container. It sucks in the bundle and starts processing. And they're fully independent, so there's no dependency when you upgrade. All logs and metrics are externalized and handled by specialized applications. So it's easy to manage, operate, and monitor. It uses standard industry components. And it has a comprehensive disaster recovery story because the gateway is now just a file or multiple files in a file system that you can handle and back up through regular tools. And it provides powerful horizontal scaling. Thank you very much. And I'm open for questions now.
Great, thank you, Michael. I appreciate that. I think we all do. The question bar is open. If you have any questions for Michael or Aran or the gang, feel free to type them in and we will take them as they come in.
Yeah, one note for the questions. As you see that HCL and Broadcom are different companies, so Broadcom supplies the gateway. So if it's product related question, maybe Aran or somebody will answer it because I'm not authorized to answer questions about the product and the future development. I can try, but I'm not the right person for that.
I'm sure you did a great job, Michael. Bill, I can't actually type in the question field. I don't know if it's disabled for everybody, but I can't type anything in there. Just to warn you.
Yeah, I think it's it might be the fact that you're a moderator.
Okay. All right.
Moderators are not allowed to ask questions.
I see a couple of test questions coming through, so it is working.
Oh, okay. There's some questions coming. Cool.
Well, just some test questions. So while we're waiting for questions, Aran, do you think there's anything else that one should think about when they're looking at doing Docker containerization with Layer 7?
Yeah, I think this fits in really well with the stuff we did last month, right, with the Istio service mesh stuff, which is really kind of bleeding edge for a lot of customers. And I know, my team has some views on whether Istio and service meshes are ready for prime time, but I think this is a journey that lots of customers are starting to go on. I know we've got some stuff in the pipeline around, policy as code and what we're calling the developer plugin, which kind of needs to be renamed. That will help in these situations. Michael, have you got any customers that are, in production with containers? That's definitely one of the topics that comes up, right? Customers think they should be doing containers. They think they should be going down this route, but they're all saying, is anyone actually doing it in production? Have you got any, good examples, names you can share, or, industries you can share where customers are actually deploying these into live environments?
Yes, I'm not sure. I didn't ask permission to share their names, but I can. Yes, we're working with one client that actually initiated that whole development. They're ramping up. They're still running the VM versions, but they will deploy and it's in QA right now. That model, they will go live with us this year. So it's not in production yet, but it's to the stage where they're testing performance and tuning. So we'll go live this year. And we also implemented the methodology we implemented also with VMs. So you can apply this to VMware just to prepare for the next step. So if you're not Docker ready yet, you can start implementing this using regular VMs. The scripts, there's a 5% variation. The scripts are a little bit different, but you can implement this model using VMs to prepare for the next step if you're not Docker ready.
Okay, and do you see any particular platforms or cloud platforms that customers are, kind of striving ahead on the containerized deployments? Is there a leader for you you've seen there? Is one more popular than the other? Are there any considerations when choosing those?
Most name that popped up is Azure. Some clients go AWS, but there's no preference. We can implement it anywhere.
Okay, excellent.
One question that just came through is, how is the Ingress managed?
That's handled, that I cannot answer, but I can take it down. And if I know who asked the question,
I'll get you the name there.
Yeah.
Several people have commented that these are great slides and they'd like a copy. Just a reminder, as I mentioned at the very beginning, we are recording this, and this entire presentation or this tech talk will be available up on API Academy either late this afternoon or earlier tomorrow.
Yeah. So the reason why I cannot answer the Ingress handling is because I developed the architecture, and the client, they had a good team with lots of Docker and Kubernetes knowledge, so they built that up over at least a year. So they did all the implementation, and they only come back to me if something is not working. So obviously it worked properly. What I can ask them how they did the Ingress handling.
Yeah, and maybe
oh, go ahead, Aran.
Sorry, Bill. I was going to say the talk from last week, although it was specifically around service meshes, was really around using the gateway as an Ingress controller into that kind of containerized microservices environment. So whoever asked that question, if you want to go onto the API Academy site and watch last month's talk, that might cover some of the topics you want to go with.
And that's where it's heading, in this direction, from what I know.
Yep.
And maybe one more
next
note.
Question.
Yeah, sorry.
Go ahead.
Yeah.
Go ahead and finish.
Yes. So you see, right now we need a leader gateway, which is a gateway with a database. So in the future, there are plans to eliminate this so that whatever tool you will be using in the future to develop policy code will be writing directly to a repository, meaning a file system, and not to a database anymore. So that step that we have now for the leader gateway, will disappear. Right now, we needed to bring all the code to production and then use GMU to create the bundle. But that will be eliminated in the future.
Gotcha. So this next question, I suspect, is more toward Aran. So API Developer Portal 4.4 encourages limited number of proxies. How do you square that with this architecture having many standalone gateways? In other words, can the portal handle having some 30 plus proxies that are container-based?
Yeah, I can answer that because that's part of the architecture. Yeah, because you see the portal is in this picture. I didn't go to the portal yet. The portal is connected to the leader gateway. So that means it's the only proxy that this portal has is the leader gateway. And because all the clones or followers inherit the complete policy structure and policy code of the leader, when it's processing, it's sending the metrics back with the same service ID and the same metrics back to the reporting tools. And the portal can consume this. So you're not connecting to the followers, you're just connecting to the leader, which gives you the repository of the APIs. And the metrics can be handled by the portal if we feed them back to the portal, or like in this case, it's handled by a different tool.
Okay, and a follow-up question, is this customer using GMU or develop a plugin from ephemeral reference architecture?
GMU. Because we started over a year ago and the plugin was, I think, just in somebody's head when we started this.
And following that logic, how are secrets such as password and keys managed with the ephemeral gateways? Is that something exported from the GMU and stored in version control?
Yes.
Well, that's an easy answer. Okay.
Yes. And in the future, maybe I specify that in the future, right now it's not perfect yet. So we have to eliminate the leader gateway. So that means in the future you will have separate components in separate files or properties files that you then merge into a bundle that is deployed to a production or QA environment, so that, for example, the policy code and the service is in a separate file. All the properties, meaning cluster-wide properties, service properties, and other components might be stored in separate files that you can then say merge these to a bundle for that particular environment or for a test environment that you spin up on the fly. So that's where it's heading. So this is the first step moving towards that direction. So that's why it's evolution of the gateway. So that's where we're heading.
Yeah, okay. And that's that work that we're doing is actively coming in. Some of the stuff that's coming in version 10 and some stuff around version 10. That could well be a topic that we could put for 3 months out, Bill. So if anyone thinks that's a topic they'd like to see, kind of the next generation of this, when we've got things like the developer plugin publicly available and Gateway 10 publicly available, then let us know and we can make that be the topic for. I'm trying to work out what 3 months is. May. We can go down that route and do that topic in May.
Yeah, because the plugin will replace the leader gateway, because the plugin will write to the file system, and there won't be no need to have a leader gateway. But the rest will stay. So it's just the core of it is deploying a gateway from a file or files.
Yep.
How you get to the file, that's a different story. And that's in develop.
And then a higher level question. How can we patch the gateway if it's Docker based?
Patch the gateway when it is not?
When it is Docker based.
You don't need to. You just create a new image and restart the Docker container.
Oh, there you go.
And the same is true if you want to downgrade, right, Michael? Yes. If you have issues, having the configuration in a file and starting up a container from that file means that if you've got different versions of your APIs or different versions of the gateway, you can swap and change back and forward much easier than you ever could before with a virtual or hardware appliance.
Yes. So you go to your Git repository, you restore the previous image, and then you trigger a script that restarts all of your Docker containers, not all at once, but in a certain order. And there you go. There's no need to patch or upgrade anything anymore.
And going back to the leader gateway, can the leader gateway also be highly available in multiple data centers and the pipeline to make reference to a different leader in case the primary is not available for any reason? Or will it be a single point of failure for the deployment pipeline?
You can replicate it like we did in the past. So it would be then a cluster in multiple data centers. And the latency then is not an issue because it's not processing. It's just a repository in the database. So there's no issues with latency between data centers. And you can have more than one.
Okay, and this next question, I believe you indirectly answered, is a plan to do a move to developer plugins and deprecate or deprecate rather, the GMU when leader gateway goes away?
Yes, that's the next evolution of this. So that's the next step in that evolution that I just showed. To eliminate, to go to the plugin, developer plugin, or something equivalent, and remove the need for the leader gateway and the database at all.
Another question, how can sync apply rate limit counters between multiple data centers?
That's done through the Hazelcast server. So the gateway has a Hazelcast component built in. You don't need a server when you stay within the data center and have only a handful of nodes. I was told by engineering maximum is around 5, because when the counter is written to Hazelcast without a server, that node has to wait until all the nodes acknowledge that they got the counter. That will introduce a lot of latency when you have a lot of nodes. So at that point, or with multi-data centers, you need a Hazelcast server. So that node will push that counter up to the server, and the server will distribute.
Okay, and going again back to the leader gateway, is it deployed on the internal network and the follower is deployed on the perimeter?
They can handle it as that agnostic. So it can be a model for internal or DMZ.
Okay. And another question is, do you have any performance data to share with us?
Yes, for that specific implementation that we did. So the client, we went through performance testing already. So we found, this is just for their particular, I cannot name the client because I didn't ask them for permission. So what we broke it down to cores. So they have, I'd say, about 200 lines of policy code with cores and OAuth, so OTK built in. So we got 33 transactions per core, because it's easier to calculate, because not the number of gateway, depends how you scale them. So how many cores you give them, how much memory they have. So it varies on the policy code, on your backend latency. But we got about, for that specific use, 33 transactions per core. But
okay,
another note, while I'm on this, it's very difficult to. I did some performance analysis for clients. There was one client, they had the gateway for quite a while, and they wanted to have all the ATMs going through the gateway to their backend systems. And management was concerned that, well, the gateway cannot handle the load, and people are waiting in front of their ATMs and waiting for this device to respond. So we did a little bit of testing. That was in a VM environment, but just give you as an example, how many dependencies are there. So without changing any code, we just tuned some VMware parameters, and we assigned static cores and static disk space to the VMs. Has disadvantage core, but just allocating specific CPUs, meaning cores, to a VM boosted the performance by factor 10 without changing any policy code. So just as an example, how many components are there? So if you have to test in your environment, because it depends on your network structure, the size of your environment you run the Docker or VMs in, what other load is going on, how much swapping is going in the background between the VMs because they're shared. So this is just one number for that specific use case that we did performance testing for.
Okay, and this is a question that could go to either one of you. What's the minimal footprint of a container?
Oh, to be honest, I don't know. Never walked into this question.
I mean, from a memory and CPU perspective, it can run on one core with probably as little as 8, maybe less gig of memory. Size-wise, the deployment is coming down with every release of the gateway.
Yes, and the reason for that is that with this architecture and where the gateway is heading, they're removing, for example, 2 million lines of code that is used just to write to the database or read from the database. So the gateway itself, because it's now becoming just a processing node and doesn't have to care about certain things, the code base becomes smaller and processing is faster. So I think the minimum footprint can go down, to 1 core, and I would say 2 gig of memory for now.
The real world, I suspect the minimal is whatever your environment requires.
Yes, yeah. But
absolutely,
I've never tested
one
this.
last. Yeah.
That's more for engineering. They might know, but I don't know.
Yeah. One last question here, and then we'll start to wrap up. My understanding is Docker gateways are mostly single node gateways with their own database. Is that correct?
You can have it either way. You can configure the Docker container to have its own local database within the container. You can have it that it connects to an external database, a separate Docker container that has MySQL. So it will be like the old cluster. So we have multiple Docker container connecting to a one or multiple or replicated MySQL Docker container, or you can have it without a database. So either way.
Okay, and then one clarification. So going back to minimal sizing, so each container minimal JVM memory size is 8 gig for starter, and I believe the answer is yes.
Okay.
Yeah, if you read it, sorry, Bill, I just read. I mean, we say at least 8 gig of RAM. That's for a production gateway. That's what we state in there, but that's for a production gateway. If you are doing something different, then I'm sure you can run it with less than 8 gig for sure.
Yes.
Okay, great. Well, that'll wrap up today's Tech Talk. I want to thank Aran, as always, for joining us, and for Michael for giving a very, very excellent chat on Docker and high performance. And thank all of you for taking time out of your day to join us, and I hope you have a great rest of the day and rest of the week, and of course, rest of the month. Thank you.
Thank you, everybody. Have a good day.
Thanks, Bill. Thanks, Michael. Thanks very much.
Okay.
Bye.